so today we're going to be talking about performance and limitations. Pretty much what that means is the stuff that you calculate using charts based on the conditions that are outside that day. So you calculate stuff for takeoff, landing, cruise performance. So that's pretty much what we're talking about with performance. Limitations is, say it's really hot out. We're gonna get more into this later, and your runway is really short. Do you have enough room to take off with that short runway? Or maybe in some instances, do you have enough room to land? Why it's important is because what I just said, sometimes outside the conditions are not favorable for flying. So if it's really humid outside and super hot out that day, your performance is going to be really bad. Do you have any idea why?
Oh, it's some denser air.
There you go. So the more dense air that you have, the better performance you're going to have, because there's more, pretty much power that's going to be being created from the engine, and the propeller that's spinning will be able to create more thrust because the air is more dense. So we're going to watch a video now about why calculating your performance is really important. So in this video, it's a really hot day outside and this guy's taking off on a dirt runway, not the best scenario you could have, and there's 3 people in this plane.
Craft's performance is dependent, among others, operating from Bruce Meadows
So you can see here that they're on their ground roll. They're still on the ground here. And it's taken them a really long time to get off. Okay, they've lifted off. And you can see how they're barely climbing right now.
That may be important.
Their climb performance should be a lot better.
What you just saw was the aircraft skipping off the ground after...
Okay, so what he's saying now is the aircraft lifted off, it touched down again, and now it's back up. We've already passed the end of the runway, and he's still barely climbing.
Not that good.
So what you should have done in that situation is aborted your takeoff. So pull your power back, come to a stop. You can still see here that he's barely climbing.
Yeah, and he's got mountains up ahead.
Okay, we're gonna skip ahead a little bit. Okay, now they're coming up on trees. They're still barely off the ground. So as you can see, it looks like he's very close to the trees.
Yeah.
At this point, he should be way higher above the ground.
My hands are sweating just watching it.
And now it looks like they're coming back down.
Are they gonna crash?
And
They're gonna
they
crash.
hit the trees.
Oh my gosh.
So,
A lot of mistakes.
yeah. Oh my. So even you recognize that
That was not good.
yeah. Grandma said a lot of mistakes. So what do you think is wrong with that situation? What should he have done differently?
He should have aborted because he couldn't get up high enough.
Maybe bring not as many people.
Oh, right.
Well,
There were 3
you
people.
were right too, but he could not bring as many people. Maybe just try to fly later in the day when it's not as hot outside, or earlier in the morning. So those guys all survived. That was fine, but that's a really classic example of why you want to calculate your performance data. So what we're going to cover is the types of different altitude, types of airspeed, and then we're going to get into the types of performance charts, which we find in the POH, which is for the plane.
POH stands for
Pilot's Operating Handbook. So, coming right over here to types of altitude, we're going to jump into it. The first type of altitude is indicated altitude. So your indicated altitude is when you're flying in the plane, it's what you read off of your altimeter. So the standard gauge, what an altimeter looks like, is like this. You have 3 needles on it. There's a short fat one, long skinny one, and then a super long skinny one with usually a triangle up top here. So this long skinny one with a triangle is for tens of thousands of feet. The next one right here is for thousands of feet, the long skinny, like kind of thicker one, and then the short thick one, this one is for hundreds of feet, and the thick one is for thousands of feet. So right now, this altimeter would read 4,100 feet. So say that the tens of thousands needle was past the 1, then it would be 14,100 feet. So all of these numbers going around can either be for thousands or for hundreds. So this could either be 5,000 or it could be 500 feet. Then these little notches in between each number are 20 feet increments. So say that this needle was at this first notch right here, it would be 4,120 feet. So that's just my drawn out version, but what it usually looks like is like this. So as I said, the thousands, tens of thousands, and 100s. Okay. Do you have any questions about that?
I don't think so.
So that's just used to know how high you are. Then you have your true altitude, which is your height above mean sea level. So what is mean sea level? Here's our little waves here, and then this is a mountain, here's our plain. So mean sea level is your height above where sea level is at. So, okay, I'm gonna talk about your absolute altitude and then I'll explain this picture. Okay, so then your absolute altitude is your height above the ground. So I just made up numbers over here. This says 3,000 MSL for mean sea level, and this says 1,000 AGL, above ground level. So right now this plane is 3,000 feet above sea level, but it's only 1,000 feet above this mountain. So why would that be important for us to know?
Well,
In the mountain.
yeah.
Yeah, you don't want to run into the mountain.
No.
So in the plane, on our altimeter, we see mean sea level most of the time. So with that being said, on a lot of the charts we have for looking at the topography and obstacles on the ground, most of the numbers will be in mean sea level, and they'll also include the AGL level. So what my instructor told me was, well, let's see, say we have like a tower right here. It's just a really bad drawing of a tower. Say this top number is 3,000, then we'll put the 1,000 down here in parentheses. So this top number is going to be bolded, which is your MSL, and this one below is your AGL. So what my instructor told me was, you're going to hit the tower when this says 3,000 feet. You're going to fall to the ground 1,000 feet. So, does that make sense? Kind
Let's
of.
see. Yeah, I get the 3,000 feet from ground.
So
Why are
in
you
this-
falling
So
100
you
or
hit it
1,000?
3,000. Like over here, you're 3,000 above sea level,
Right.
but you're only 1,000 feet above the mountain.
Gotcha.
So you're
Yeah.
only, if you were to hit the tower right here, you're only gonna lose 1,000 feet before you hit the ground.
Gotcha. Yeah. Okay. Thank you.
Okay, so true height above mean sea level and absolute height above the ground. Next, we're gonna talk about pressure altitude, which can be a little bit confusing, as well as density altitude. But pressure altitude is your height above the standard datum plane. So that's just like a theoretical level at sea level where the standard pressure is 29.92 and 14.7 psi, or pounds per square inch. So there's a couple ways to calculate your pressure altitude. First, you can use your current altimeter setting and then subtract it from standard. So say the altimeter setting is 30.30. You're going to subtract that from standard, which is 29.92, and you're going to get 0.38. You want to multiply that times 1,000, which gives you 380, and you're going to add it to your field elevation. So 624 is the field elevation at Traverse City. So that's going to give you a pressure altitude of 1,004 feet. The second way to figure out your pressure altitude is you could go out to the plane. This is the part you guys won't really get. But you could go out to the plane, and with your altimeter knob, you can set in 2.92 on the gauge and then read what the altitude says. And say if it says 1,004, that's how you know what your pressure altitude would be. Then there is the chart that you can look at. So this is your pressure altitude chart. So our altimeter setting is 30.30. So you're going to subtract 348 feet from 624. I didn't do the math for that, but that's how you would use the chart. Okay. And then one other thing to note with pressure altitude is that it's important to have the right pressure altitude, because above 18,000 feet, the jets are flying at pressure altitudes is what you say. So once you get to 18,000 feet, you set in to 9.92. So it's pretty much a standard for all of them up there. So it just helps with vertical separation between the planes. Okay, then the last thing we're going to talk about is density altitude. So the standard definition for that is pressure altitude corrected for non-standard temperature, and that probably doesn't make a ton of sense. So it's your feels like attitude. So say you're flying at 5,000 feet, but the density altitude that day is 7,000. Even though you're at 5,000 feet, the plane is going to feel like you're flying at 7,000 feet. So the issue with that is that compared to 5,000 feet, 7,000 feet, the air will be even less dense, so you're going to have worse performance. So there are two things that kind of affect this: temperature and moisture. So the hotter the temperature outside, the further the air molecules are going to be separated, which will create less dense air and worse performance. And then there's moisture. Water vapor is lighter than air, so having a humid air outside, you're going to have less dense air because the water is taking up more of the molecule's room, I guess is a way you could say it. That's kind of what my instructor said to me. So what I have over here, a high temperature. High temperature gives you not dense air, which gives you bad performance. Then same thing, high moisture will give you not dense air, which again will give you bad performance. So when you're on the ground, that's where the pressure is going to be the most, and you're going to have the most dense air. As you go up in altitude, your pressure and air density will always decrease. So as I said, you want to have dense air. Dense air is going to give you better performance, and this can get kind of tricky, but it'll give you a low density altitude. So the way I like to think about this is when you're low on the ground, you're going to have dense air, which is good. The opposite of that is having a high density altitude, which would be bad. So if you're high in the air, you're gonna have less dense air, which is bad. That's kind of how I remember that. So what you want to have is a low density altitude, and that'll give you good flying conditions. So what we watched in the video, he had probably a high density altitude, which means that his performance wasn't going to be good. So the two ways for finding your density altitude is on the chart and using your E6B. So we're going to look at the chart first. Okay, so we're just going to make up some numbers for a random example right now. So say it's 10 degrees Celsius outside and your pressure altitude that you calculated is 6,000 feet. So you're going to follow this up to 6,000 feet and go across, and that gives you a density altitude of about 6,800. See density altitude over here. Okay, then the other way you can find your density altitude, we'll go over here. So we're going to use the same exact example. So here you can see you have your air temperature, which is over here, and then your pressure altitude in thousands of feet, which is right here. And that's going to give you your density altitude right up here. And these are all in thousands of feet. So you're going to set 10 degrees Celsius. Positive is going to the left, so it's this bigger line right here. You're going to set 10 degrees Celsius at 6,000 feet pressure altitude, which will give you a density altitude of 6,800, because each of these are going in thousands of feet. So each little hash is 6,000, 7,000, 8,000, 9,000, 10,000. And I don't know if you can tell, but it's not quite on the 7,000 line, which is why it's around 6,800. So those are the couple ways to find density altitude. And those 5 are all of your types of altitude. Next, we're going to be going over types of airspeed.